My name is Tim, founder and CEO of StartProto, here with one of our great customers for another shop tour. We're here with Cody at CAMaster. So we'll go into a little bit of what CAMaster does.
Absolutely. So welcome to Cartersville, Georgia. My name's Cody Smith. We're here at the CAMaster manufacturing facility. We manufacture CNC routers here.
Cool. Yeah, all USA made, super cool machines. Go through kind of some of the industries you guys serve.
Yeah, absolutely. So one of our bigger industries is going to be custom cabinetry, anything to deal with wood, right? So built-ins, bookcases, kitchens, bathrooms, that kind of industries. But then it goes way beyond that. We do quite a bit in the automotive world, customizing cars, hot rods, plastics, so panel processing, producing parts. Our routers are probably found in just about any industry out there.
Yeah, I know. I was even at our trade show builder and saw one of your machines, so they're all over the place. But cool. Yeah, I think next we'll go kind of talk through a little bit about the sales process and kind of how you guys help your customers choose your machines. So,
Sounds great.
I'm excited for that. Cody, let's just start with, okay, a customer reaches out to you. What's the next step for them?
Of course. So the first thing we want to do is find out what problem they're trying to solve, right? So it starts with finding out the type of material that they're going to be using, the space available for the machine, and then of course the different options they're going to want. A lot of the options are going to be based on the material and the size, right? And of course flexibility in the product. So a lot of our machines here are very custom, right? And with that means we have a lot of different parts, a lot of different components and assemblies that we needed to track here. And that's really what we needed StartProto's help with.
Yeah, I'm seeing here, even this machine's got a ton of different head options on it. I know kind of what that looks like in our software, but kind of just talk through what that looks like for the customer.
Of course. So this is one of our Sign Pro machines. So if you can imagine, it's geared towards the sign industry, right? So this machine has your standard typical automatic tool change spindle, and then the tool rack is in the very back of the machine back there. But in addition to that, we also have an oscillating knife that we have to produce here, a non-oscillating tool change knife. This is really great for cutting materials like cardboard or for creasing packaging, and then a laser engraver as well. So all of these different components require a lot of different parts that we produce here. And again, more efficient tracking increases our production, allows us to produce a lot more machines.
Right. Yeah, and it's not super simple, right? Because every time you have one of these options, it changes the head assembly, changes your gantry, changes all of that. And
correct.
I know that's kind of where you've been able to provide a lot of value.
Yeah, and StartProto's really helped us get more efficient in what we need to produce. Instead of saying, hey, we're going to produce 2 heads today because that's how we used to do it, we may produce other components knowing that we need different things for the machine, right? So it helps us spend less time machining. It allows us to increase the efficiency again in how we produce, and it helps us get these machines out of here quicker.
Cool. Yeah, I think next we'll talk to engineering and kind of see what that looks like in StartProto to configure, and then go into kind of what it looks like to machine all these different plates and sub-assemblies. And yeah, we'll go from there. We're here now with Will, the primary design engineer for CAMaster. I'm going to go through a little bit of kind of what it looks like after Cody and the sales team sell a machine. So kind of what's your guys' first step? Obviously CAD, configuration.
So you start at the drawing board, and then you can go from there, and you can start with initial CAD, you can start building some test models, and then you can actually start going into fabrication and making test parts. So you want to make sure that everything you have is tested, make sure that you can put it through the design rigors, and make sure that the actual requirements, the part that can withstand all those requirements.
Cool. Yeah, and then I know a lot of your time is spent on sort of R&D and kind of developing these base machines. Obviously you guys have a couple different product lines, all that's largely standardized here in CAD, right? But then you guys have a ton of configuration that you do as well, based on what options the customer chooses. So obviously that happens in CAD, and you've been doing that there for a while. But I know one of the things we've been doing with StartProto is actually taking some of those variables and putting it obviously into our system so that it can ultimately drive the shop floor. I guess talk through a little bit of your experience kind of working with that and kind of where you see that kind of taking you guys through the next few months.
Sure. Well, we try to take a very modular approach. That way, if you have a certain option, it's always easiest if you can just bolt on and go. But some things have to be more specialized, and you have to know, hey, if I have these options, I need to make sure that the foundational base can support that, and so on. So when you're trying to define it in the StartProto system, we have to know how that design hierarchy stands, and basically have the right design steps and the right build steps to make sure that in the process the right steps are followed to get the right result.
Right. And yeah, it's everything all the way down from, you know, the length of your gantry tubes, and obviously a lot of it's to driving your purchasing to the different kind of sub-assemblies and kind of, especially the longer lead time components, right?
Yep.
So
Changing a frame size, a gantry size, the height, all of that can correspond to not just to different steels, different SKUs, but also cable lengths, other different types of configurations of components that you might have. So all of that can change all of the smaller components. That way you can match the end result to what the customer ordered.
Cool. Yeah, and obviously I think you've been the primary driver of kind of building that configurator. I guess talk through kind of what you've been seeing, obviously working with our engineering team and the APIs, kind of what you've been able to build there.
Sure. So the configurator really helps it to make it streamlined, so that way you can take someone who doesn't necessarily know all the intricate details of what parts change, but if we can build that on the back end in the StartProto system, we can then take all of those unique items and we can basically have a set of items that you just have a work order and you go and select those options. It'll automatically select the right ends on your back end. That way we can populate a machine work order that has all the right selected components and assembly items that match the work order.
Cool. Do you want to just run us through real quick, a quick cool demo? Yeah, so obviously on the left here you have your CAD for a machine, and then here on the right you have your configurator, so kind of walk us through, you know, what you might get from sales, and then kind of how you're putting those variables in here.
Yes. So let's say we had a Stinger 4x8 ATC machine. We could go and assume that they had, let's say they had a Performance Package Plus, we could select that as an option. Let's say they had a phenolic tabletop with vacuum grid, and let's assume they added a 14-watt laser engraver to their machine. So we can add all this. We could add in, let's say they added cat leveling feet for that. On the universal options, we can go and select items that they might have added. So they might have added a maintenance kit, they might have added a starter bit set, and they might have added a half-day of in-house training. So we can go and add all that on. We can even go and add on some of our third-party options. Let's say they added on a Hurricane vacuum pump, and let's say they added a jet dust collector. I can add all those on, and I can go over here and I can review all the information that I've selected. Then I can go and I can submit this, and that submits all of this information to the StartProto system. That way this populates as a job that we can then release and track on the work floor. Yeah.
So we're hitting submit here, and then we'll get
So you hit submit, and we go through, it'll parse all this information, it'll submit it to the cloud, and then we're ready to go. And inside here, we can see we've got our machine, Stinger 3, and inside here has multiple different parts, and each one of these parts is part of a larger whole. And for example, if you were to go and break down each of these can actually lead into further more options. So some of these things go into parts that we machine here. Some of these are parts that we fabricate internally or we order externally. So you can kind of go through the list and see all these options that we've added on and see what they take.
Yeah. Cool. Yeah, anything else on this you want to share? Anything kind of that you see kind of expansion of this as you go?
You know, the big part about this is to be very user-friendly. As we go and add options, we have very simple ways of editing JSON files to add options. So as more options come up, we don't have to rewrite the program. We can just add those options and put their corresponding IDs from StartProto into the JSON file, and then we can go and customize our machines further. So as we develop new features or have custom options, it's easily added into our system.
Yep. Just do it once, and then
exactly.
You know, ideally, you're not getting a ton of questions day to day as you're developing the next big thing here. So cool. Well, Will, thanks so much for walking us through that process.
Thanks, Ed.
And I think next we're gonna go on the shop floor, talk with Eric, and kind of see how all this actually gets executed.
Now that we saw some of the engineering stuff in the front office, we're out here with Eric, who's a production manager here at CAMaster. We'll kind of walk through what goes on. So when you get an order from engineering and sales, what's your kind of process? What do you check? Where do you go from there?
Just looking at the type of machine and the options that are on there, and seeing if there's anything that needs to be updated with engineering, or if it's just a standard machine, we just go ahead and create a work order and send it out to the floor.
Yeah, so you're getting that order from them. You're checking all your sort of sets. From there, you're checking the purchasing list. You're checking all that stuff. A lot of that goes through StartProto as well, right? So kind of talk through what information's there and kind of how you use that as a tool to manage the floor.
Okay. So we have a step built in for each station. So we'll go in and we use our configurator. We'll just go ahead and put in all the machine options, and we have a BOM built for everything, and it'll start putting out different projects for everybody on the floor to start working on. So it starts in electrical and subassembly and machining, and then it moves out to frame prep, and then pre-assembly and final assembly and testing. So.
Cool. Yeah, and that's where you do your QC, and then after that, I guess you just ship it out the door and
Ready to go.
right on there.
Yep.
Yeah. Walk through a little bit about how StartProto is part of that. I know you guys are using it to kind of track where machines are at, consume material. Yeah, kind of what are you most excited about having that do?
So just tying everything together with one software is great. You know, we've had purchasing, and then we've had a independent spreadsheet in the past, and just being able to put everything in one place and everyone knows where the machine's at in the process it's been great.
Cool. Next, I guess we'll check out the different sub-assembly areas. What's your recommendation to go to first?
Probably start with machining or assembly on itself.
Cool. All right, well, we'll go there. All right, we're here with Richard now, looking at their kind of machining process. So I know you guys machine a lot of parts in-house. Talk through kind of what that process looks like, how you guys are getting to work, what parts you're making, that sort of thing.
Okay, well, we start out with these raw sheets of aluminum, 12 by 12 usually. Some are 1/2 inch, 1/4 inch, 1 inch material, just depends. And then we cut it over here on the bandsaw to whatever size it is that we need. We load them up into these machines, and we try to make sure that they're surfaced to within a certain tolerance. We do our side plates, transmissions, different things like that. So we continuously have 4 machines running at all times, or as close to all time as we can get. So
cool. Yeah, and then I know you guys, between you guys and engineering, you figured out kind of a process to nest a lot of the parts that go into certain sub-assemblies at once, right? So you're able to kind of cut most of a head or a side plate or something kind of in one run, right?
Right. We get they give us these diagrams to go ahead and do the programming for us and stuff like that, and then we get these diagrams, and it's all making sure it gets set up and that it's within a certain tolerance. A lot of miking and stuff like that's involved in making sure that the material's just the right thickness, getting the holes tapped and getting it all lined up just right. And it's it's easier that way, so it takes up less time for the operator to do the programming. So they do the programming, and then they give us the program, and we can run several programs a day real quick, just boom, boom, knocking it out.
Yeah, and then you guys are to some extent trying to aggregate, like if you have a bunch of Panther machines to cut all those together. If you have a bunch of Cobra machines to cut, you'll cut all those together, right?
Oh yeah. No, we have a set like dates and times and stuff like that, and then we go and check every morning, like, hey, all right, we got to cut a list of these Stingers or Cobras or Panthers, and then we just knock it out. Hey, I need this many of these and that many of those, and we just, we're able to do several sheets in a day.
Cool. Yeah, I know. I think you guys might even beat some of our machine shop customers with your spindle uptime. So super impressed to kind of see this area, and yeah, I think we'll head to one of the other sub-assembly areas next. Thanks so much, Richard. All right, we're here with Kevin to go through electrical sub-assembly. So, Kevin, what sort of information are you getting from production engineering, and kind of what do you do with that in order to actually build the panels that run these machines?
Sure. So we'll get a work order, and then we'll tag team the tasks between us as far as getting prepped for that, getting nameplate engraved and file folders ready, and then of course whatever we're working on for the week might get 2 panels a week done or something like that, just depending on how involved the panel is or other tasks that we have coming up. Sometimes we have some soldering that we need to do, bands for monitor stands or motor starters that we have to put together.
Yeah, and then obviously there's a couple different controllers and stuff. You guys are pulling that stuff out of the stock room. You guys are programming it, kind of walk through some of the considerations there that you have and information that you need from others, or parts that you kind of need, and then sort of stuff like that.
Sure, yeah, we've got several different controllers, whether it's a Centroid or Scala controller, stepper or servo motors, what kind of spindle or cutting head, and then auxiliary options. That'll impact how we build the panel and what components go on it.
Cool. Yeah, anything else we should know about electrical subassembly? I mean, obviously this is kind of what runs the machines, and
Yeah, of course, our focus is the control panel, and then peripheral things like motor starters or soldering certain components that get used elsewhere, odd projects coming up here and there, special case work orders. We'll do a little research as far as what we might need to use as far as a VFD or wiring considerations.
Cool. And then from here, you guys are staging it, and it goes to just assembly, right?
Yeah, they can grab the panel and put it in the control box and start tying everything in, give the machine power, and start dialing it in.
Cool. All right, well, thanks for walking me through electrical here, Kevin.
Yeah.
And yeah,
Pleasure.
we'll move on to assembly. Cool. Yeah, we're here now with Ethan. He's gonna talk us through a little bit about how the frames get prepped to go into assembly. So, Ethan, I guess, what are you kind of getting from your vendors? What are you doing from there?
So basically, this is how the frames come to us from Steel Materials. We drill these holes out on our machines here, and then they come to us from Steel Materials, powder coated. Get it all powder coated, get it all set up ready for assembly. Frame prep. We have to tap these holes out. We have to make sure everything lines up correctly. Put the gear racks on, put the rails on. After we do that, we put the side assemblies on and put the gantry on, and then we're ready to roll. Basically, during this whole process, we're just making sure everything lines up, everything's shimmed correctly, everything's sitting flat and ready to cut well.
Cool. Yeah, let's take a look at one of the machines that's had that done.
So this is one with the gear rack already set and the rail on the underside here. This is an undercarriage machine. Basically, what we do is we put a level on this gear rack and just make sure it's level all the way down, and then bolt everything to the frame. And then after this process, we put these bearings on while we're doing this. Basically, we put the side assembly on, attaches to the bearing, and then after this process, we put the gantry on and make sure everything's good and red on that as well.
Cool. Yeah, and then over here, you guys have parts coming from your stock room and other kind of parts of the shop, kind of gearing up for this next stage of assembly, right?
Right, yeah. So this is our pre-assembly, pre-set up bins, basically. So we have our wires that we cut out. We, pre-measure the wires, making sure that they're all set up correctly with their Molex pins and whatever they need to connect to, solenoids and everything like that. We also have our spindles in here with the aluminum spindle plate that attaches to the head. Basically, we try to pre-assemble as much as we can coming into these machines and making sure that everything's tight, everything's Loctited, everything is set up and ready to go. As soon as these machines get their gantries on them, the rails and everything like that, basically we are ready to go on those machines.
Cool. All right, let's take a look at what this looks like one or two steps further once it's been assembled here.
Yeah, so basically when we're starting the assembly process, we're putting this spindle on up here. Everything that goes on up here, laser engraver, laser crosshair. After that point, we're kind of running all these wires this way, along with attaching these motors, limit switches, everything that goes on up here, lining up this Z motor plate here, making sure everything's, cutting straight and making sure it's running exactly level with the machine. After that process, we're running the wires down through here, attaching these motors and transmissions, running these air lines where they need to go. Air lines need to be running to the spindle, to different solenoids back here, everything that goes into that. Air regulators and whatnot are running back here. There's a lot that kind of goes back here. It looks a little packed, but we try to fit as much as we can on these things and condense them as much as possible while still maintaining the productivity and whatnot. After that process of running everything here, putting everything on, we run things down through this E-chain, the wiring and everything like that, and they start running to the control box. During this pre-assembly process, we also install this control box. We put that on there, run all the wires down to it, attach the motors on the side assemblies and everything, attaching the motors and transmissions, putting the toolbar on, tool cones, everything mechanically basically gets done before tie-in as much as possible. As soon as the wires are ran down to tie-in, then we're good and ready to lift the machine up and get it ready for tie-in.
I guess let's go check out a machine that's kind of ready for that step here.
We can go ahead and
one over.
Yep, jump on over.
After you gotta have everything pre-run here, you're getting this panel from electrical, right? And then just hooking everything up?
Yep, so we put these panels in here. Basically all these wires that are running from the head and the side assemblies, the motors and everything like that, all of that runs into here. So during this process, we're running all these wires in and basically tying them in wherever they need to go. We have the I/O board up here. We have an expansion board, all these double stacks, you know. A lot of wires going everywhere, but it all gets to where it needs to. Laser engraver setup right here. Basically just everything runs into here. VFD's on the opposite side, so it runs on the opposite side of the control box. And then we also have the on-off switch and everything like that that gets run on the other side of the machine. All of those wires get tied into here. Basically, we label them as they come in. So every wire comes pre-labeled, and basically we just have these sheets right here that tell us where everything goes.
Cool, so I guess after control panel tie-in, you're pretty much mechanically done, right?
Yes.
And then you're going into calibration testing.
Yep.
Walk us through some of that.
Yep, so all after tie-in, everything's wired in. Basically plug it in and ready to go. As soon as we plug it in, we basically open up the software, make sure everything's installed correctly, putting every macro, make sure every macro works and whatnot. Basically go into squaring and making sure the machine is cutting correctly, squaring, framming, resolution, everything that kind of goes into what makes these machines actually cut correctly. After that process, basically we go into testing and tie-in and QC. I'm sorry, not tie-in, final and QC.
Cool. And then at some point along, you guys are actually machining these tables on the final machine, correct? And they have grids and surfacing operations.
What we actually do here, basically we have a machine that we cut it on over there. We cut these tabletops out. Once the machine has done all of its cut tests, basically the trimming, the squaring, making sure the machine is cut correctly. We cut up 3 different files just to make sure that everything is cutting correctly. We cut a 3D file, 2D shapes file. After that process, we basically put the tabletop on. If plumbing is needed, which it is on this one, then you basically put these shower drains in. We lift the machine up again, run the plumbing in very briefly underneath. That usually only takes a little bit of time. It's just running some PVC. And after that point, basically the machine is ready to go. Depending on what process that they have after, you may have to set tool locations for your tool forks or your tool cones. Maybe put a spoil board on there as well if that's needed. But after this process, basically goes straight to final and QC.
Cool. Yeah, and then from there, it's just on the truck and out the door, right?
Yep, after final and QC, yes. We try to do as much final and QC before it leaves. You know, we're constantly trying to adapt to what customer needs are, what getting feedback from our customers and whatnot. Trying to figure out, you know, what could be improved as we go forward. We're constantly listening to feedback, constantly adding to what we need to check. And as far as cut tests and whatnot, seeing how better we can improve the machines. Everything gets checked during the final, and then it also gets rechecked during the QC, basically.
Cool. Yep. All right, well, Ethan, appreciate the walkthrough.
Yep.
And yeah, we'll go from there.
All right, that wraps up our tour here at CAMaster. Thanks to everyone here for showing us around and seeing a little bit about how the StartProto software interacts with the process here. If you or anyone else you know has similar issues on the shop floor, feel free to reach out to us via our website, try the product out, or speak with anyone on our sales team to consult about your process. Thanks again for watching, and we'll see you next time.